Very good morning to all of you present here in the session. This is your first lab session of DA. So I'll give you a little bit of introduction about how the lab is going to get conducted in the entire semester, what all things you need to take care, okay, where you are supposed to submit, fine. So I'm going to give you an overview like that, and you are supposed to follow that same thing, okay, in the entire semester. Just let me present you my screen. First of all, I'll let you go through with the experiments that we are going to cover. Okay, screen is visible to all.
Yes, ma'am.
Yes, ma'am.
All right. See, I told you that in the teaching and examination scheme, the term work part, this one, okay, is of 25 marks. All right. So 25 marks of your lab work. That term work is nothing but your lab work. Okay. So 25 marks of that. And in those lab work, you have in total 12 experiments to be done. Okay. Now don't think that it is 12 experiments, so in 12 labs everything will be over. No. You see here implementation and time analysis of sorting algorithms, where you have this sub question: bubble sort, selection sort, insertion, merge, and quick. Right? So you are going to do what? Implementation and their time analysis. Okay. The second one, again, implementation and time analysis of linear and binary search. Again, implementation of max heap sort algorithm. Time analysis of factorial program. So, and it is again using both iterative and recursive method, right? So it is not like one experiment, one lab and over. Okay. So please don't be in that particular world. Secondly, I am going to start today after the explanation with your experiment number 2. Okay. Implementation of linear and binary search algorithm. This time analysis part we have not covered in theory yet. Time analysis is nothing but your amortized analysis, that is big O notation and theta notation, small o, those, okay, omega notations, those. So that is what your time analysis, and that there what you are going to do, the worst case, best case, and average case. I do remember some of you were asking me in data structure when we were discussing this linear and binary search, that when you are referring any online particular references, okay, you are coming across lines where they are saying that the algorithm takes n log n time or big omega time, okay, or theta, big theta time, right? So what is this? So here is your answer, because that time I used to tell you that you will understand it all in your higher semester. You are here in the higher semester, and this is the answer. They are all the time analysis of your algorithm. And why we are doing this time analysis? Because we want to enhance, we want to speed up the system, or say the algorithm that is working. Okay, so when we discuss those time analysis part, then you can go and do the time analysis or comparison of linear and binary search algorithm. Okay, today, first of all, okay, that is it about the lab session. 12 practicals, okay, first 12 practicals. Syllabus file is already uploaded. Book, it was taking a time from my home network, so I'll try it again today from here. Okay, so book you can Corman, I told you I will upload it by today. At my home it was taking a little bit of time. This syllabus file is already there, so for your reference, all these 12 practicals you can see. Now coming to the format of submission. First of all, where to submit, I'll tell you. I'll represent my screen again. Visible?
Yes, ma'am.
Okay. See, this is the word format tutorial 1. Okay. In the footer, you have enrollment number, batch, and page number. Okay. Implement experiment number 1, or you can say tutorial number 1, implementation and time analysis of sorting algorithm. The question. Okay, the question from your syllabus file. Number 1, bubble sort. You are supposed to write the algorithm first. Algorithm, not code. Okay, write the algorithm first, then you write the code, copy paste the code, you do time complexity analysis, and then you give the output screenshot. Okay, you have to use Times New Roman with 12 as a size everywhere. You see, it is Times New Roman 12 size. Here also Times New Roman 12 size. This also Times New Roman 12 size. Okay, this is how you are supposed to make the format, or say the submission. If any student, see this I repeated in your theory session also, again also I am telling you here in your lab session officially. The first and the foremost thing that I am going to check, if I go and save it as PDF, let me do it, you have to do it like that, this only. Okay, save it as PDF. I'll upload this Word file in your e-content. Okay, save it, and whenever this tutorial 1 is done, okay, you save as PDF. Let me present again, wait, I'll do the entire screen this time. Visible? Once you're finished, okay, once you're finished doing your experiment, okay, the changes in this Word file, okay, you publish or you save it as a PDF, and then you have to submit the PDF, okay, in the Google Classroom invite, which I shall be circulating you amongst you after this session. Okay, the Google Classroom invite. It will be specific to the batch. So don't go and tell that, madam, my friend from B batch is not here, I cannot see. It will be specific for the batch. Okay, so Google Classroom for your batch, A batch, will be there. Okay, whenever I'm posting to submit the practical, you have to submit me those practicals, and it will be like within 2 to 3 days after I complete the tutorial in the lab. Okay, I'm not going to give you 1 week to complete one tutorial. It will be within 2 to 3 days after I finish the explanation and everything that is to be done with the tutorial. So please be ready with that mindset. Okay, after you do this formatting, you are submitting it in the Google Classroom. Okay, the very first thing that I'm going to see is this formatting. I'll see the formatting like this: header, okay, tutorial 1 done, enrollment number, batch, page number, okay, fine, everything is perfect according to my format, which is this one, which you can see on the screen. Then and then only I will go and see what you have done the experiment. And please don't do any innovation, any changes in the format. If it is asked here to write your enrollment number, then just write your enrollment number, no need to mention TC3. It is asking you to mention just the enrollment number. It is asking you to give just batch. So A batch is sufficient. It is asking you page number. So page number -1, you don't have to write. Just write 1, it is enough. Okay, please don't go and do any innovation here, that batch is here, then enrollment number, then page number. And please don't come up with an argument that, madam, all the required information is there, just the order is changed. Format I am providing you for a specific reason, and that format you have to follow. If you cannot adjust, some problem is coming, you adjust your content. Don't adjust my formatting. Okay? Everyone is clear? All 21 of you?
Yes, ma'am. Stay.
Yes, ma'am.
Yes, ma'am, it's clear.
From the day one, students, see, I am telling you in a very clear instructions that don't go and change anything in this format. And that's why I am going to provide you this Word file. Okay, I'm not even going to give you the PDF that you convert it online into Word and then you do the job. No, I am going to provide you this Word file in your e-content itself. So whenever you want, by chance you are missing out or you did not save the Word file, okay, then you go back to your e-content and you download. The file is there with you. But whatever is mentioned and whatever is the font size, don't even go and change the font sizes also. Okay, see, this tutorial one is what, Algerian 72. Keep it like that. Okay, keep it like that only, and that should be in the first page only. Here enrollment number is asked, then just write this enrollment number only. Okay, XXXXX, something like this. Okay, so just number. Please don't write like this. If I find this, straight away I'll return you back. No marks also. I'll simply return the document back, because the very first thing I'm going to check this time is the formattings. And this right now you must be thinking that why ma'am is doing this, so much of hassle, why so much of importance to the formatting. You will get to know when you are, giving the submission of your final project and your work profiles. It is for you to get used to for these kinds of formattings. In your final project, in your work profiles, formatting is the very first thing to be seen for your work. You will be always appreciated when you do the formattings absolutely right and on point. Okay? The work is excellent, but the way you present your work is poor, then nobody is going to check. Nobody is going to check your work inside. What is the question? No, I don't want any colon. If it is written as batch, then you just write A batch. Simple. Okay, like this you write. Page number, you write it as 1. Though you can make settings here. Okay, there is a setting here to make it in a, because everywhere it will be C111 later on, and every time like you have to go and change. But in this footer settings, you get the settings also. See here in this edit footer. Okay, right now it is in this blank format. Okay, 3 columns, but you can go and edit the footer if required. Fine. Everyone got the point? Don't change anything. This is in Algerian 72. The rest of the things are in Times New Roman here, your content of size 12. Keep it as it is. Question is in bold, so keep it bold. The heading is bold, algorithm, keep it bold. Okay? An output screenshot, this one, I'll write it for you. Keep it in center. Okay. Everyone understood clearly all the instructions?
Yes, ma'am.
Okay.
Ma'am, excuse me, ma'am.
Yes, Suman.
Ma'am, the answers should be in bold or
Just the heading.
okay, 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 ma'am.
Anyone else having any doubts? Yes or no? Okay. We are starting with your experiment number 2 first. Okay, implementation and time analysis of linear binary search algorithm. Talking about linear algorithm, linear search algorithm first. Okay, what do you remember about linear search algorithm? What is a linear search algorithm if you can remember? Anyone? Speak up. Otherwise, I'll start picking up student.
What, ma'am?
Linear search algorithm. What do you remember? We have seen this in data structure. Sequential search. Right. Search in array through index numbers in ascending order. Yeah, correct. Entire array one after the other to get the value. Correct. Oh yes, one more thing I forgot to tell you guys. Uh, this particular list of experiment, 12 experiments, you can choose C or C++ to perform. Okay? You can choose either C or C++ to perform the implementation of these particular algorithms. But I will be explaining you using C language. Okay? You guys can choose between C and C++. Second thing, you have to keep only one language in this entire 12 experiment. Please don't do that first 3 experiments you are doing in C++. Fourth and fifth, you are finding it difficult, so you did in C. Again, 6, 7, 8, 9, 10, you are doing it in C++. That hybrid mode I am not going to allow. If you are doing it with C, you do all 12 in C. If you are doing it with C++, you do all the experiments 1 to 12 in C++ only. Okay? Fine. Now, if you can remember this particular Excel sheet, do you guys recall this Excel sheet that we discussed in DS? Where I took the example to explain that a linear search is defined as a sequential search. Okay, the size of an array is 8. So see, index values are from 0 to 7 with a given values at each of the index. And the data that we were taking from the user to be searched was 2. Now what we were doing, we were searching whether this 2 is present in my linear array. Okay, and we were searching it in a linear fashion. So we were doing what? We were following an algorithm. So see students, this is what I mean by algorithm. Okay, this is algorithm. There you am not giving declare the integer in our array and then you write the array and then you go and declare integer I and a and n. Nothing like that. This is what I call algorithm. Okay, or a pseudocode. So in your here where I'm asking you guys to write algorithm, okay, then only the main portion will go. And in that main portion also, not the code part. Okay, this is the pseudo code. So you can represent it in the step by step. Step 1, take a for loop. Okay, then step 2, do an if condition, something like that. Okay, then when I tell you that you write code, then you are supposed to copy paste the whole code. Okay, starting from your hash include, okay, or your initialization void main, fine, printf or cout or c in anything. And then you are supposed to write the time complexity, that is the best case, average case, and worst case, the comparison. Okay, and then comes your output screenshot of that particular algorithm. So we are starting with your linear search here. Okay, linear search. If the element is present, for I is equals to 0. Now here I is what? I is your index values. So we are going to increment your index values every time. Experiment 2 in the chat. Yogaraj, you can find out the file actually in your e-content also later on. I don't mind doing that. Here you go. Okay. So in this for loop, what we are doing? We are taking I, and what is that I? Your index values. So every time, once the search is over, we are incrementing the index values here. Okay, to move forward. And inside that for loop, what we are doing? We are doing a of I equal data, right? So a of I, what is a of I? Whatever is the index value right now going on. So a of 0, that is 15, and 15 we are comparing it with 2, right? As soon as we get the our required value, we got the required value at index 4. Okay, we are doing what? A break statement. Okay, simply we are breaking the loop, right? So that was what we were doing when the element was present. Now, what if my element is not present? Let's say the value we take as 80. Okay, so my whole search will go till here, till 7. At 7 also it is not getting the required element, that is 80. So what it is going to do, it is going to increment the value of I. So I value will be 8. Now 8 is also the value of size of array. Okay, n is equals to 8, that is the size of array. And when I value, index value, and the size of array are same, you can say you have reached the end and the element was not found, right? So if you want to do the step by step how you are going to write this program, first what you need to do is you need to create, fill up, and display the array. Take one array and try to fill it up dynamically. Okay, don't hard code the values, try to fill it up dynamically. Take the values from the user that enter the value for the array and display that array. Once it is done, you take the input from the user to search the element, which element he or she wants to search. Okay, then you go, excuse me, okay, then you go and write the logic of when the element is present, and then write the logic of when element is not present. Okay, now in this time analysis, you just wait for me. Okay, I'll give you time to write the code. Please don't write it as if you're writing it right now also. Okay, stop it right now. Okay, now in the time analysis part, what time analysis you are going to do? Okay, you are going to do the time analysis part is in terms of best case, average case, and worst case. Okay, these are the three time analysis, time and space complexity, if you have heard somewhere. Okay, so we are going to discuss that in these terms: best case, average case, and worst case. Now for this I'd like to take one example. Let's say you guys have a cupboard in front of you, a cupboard full of clothes, yours only. Okay, a cupboard full of clothes. Let's say you are searching for a specific kind of a t-shirt. let's say dark navy blue t-shirt. Okay. So what is the best case in this? If you are searching for your t-shirt, what can you think of a best case? Please be interactive here. Don't write in the chat. Unmute yourself and answer me. What is the best case in this scenario? You are searching for a dark blue t-shirt, a favorite t-shirt of yours, in a cupboard full of clothes. What is the best case?
The T-shirt is right in front of us, like in the first pie we
It
get
will
it.
be easy.
Exactly. Yograj, you are also right, but I would appreciate if you can speak. I don't know why you are not speaking, but okay, fine. Um, exactly right, both of you, Vikash and Yograj. When the search is pretty easy, that means the t-shirt is right in front of your eyes, or it is hanging on the hanger as soon as you open the cupboard. So that is what the best case is. In this technical terms, if we talk, we are searching for what? 2. Now, let's suppose 2 is somewhere in the middle as of now. If my 2 was here in place of 15, here is the 2. Okay? Let me do no fill here. Okay? In the first iteration itself, I'm getting my required result. So that is what the best case for me. Okay? Now coming to the average case in terms of the t-shirt example. When can you say that it was an average case search?
If it is in the middle or something like that in the cupboard.
If it is in middle somewhere. No, I'm talking about in terms of your t-shirts. You are searching for your navy blue t-shirt in your cupboard full of clothes. What is the average case?
When we didn't find the t-shirt, but the t-shirt is in cupboard.
No, not exactly right, Vikash.
We search for 2 and 3 T-shirts, and then after we find the T-shirt we want.
Correct. See, the average case in that t-shirt example happens when it is not in front of you. You have to at least, search through 1 or 2 piles to get that t-shirt. But you get the t-shirt. Okay. In the best case, it is right in front of you. In the average case, you have to search through the pile, 1 or 2 pile, and you get the t-shirt. Okay. So in our case here, if 2 is in its original place, okay, then we can say that it is going to be the time analysis for searching 2 will be somewhere in that average case part. See, this is not the exactly how best case, average case, and worst case work. Okay, please don't be in that impression. But because we have not, you can say, covered the time analysis part in the session, theory session, so it is easier to understand like this. But please don't understand that this is what it is. Okay, there is something more to it of how you can decide that this is the best case or average case or worst case. Okay. All right. So this, when we are searching for 2 and we get out after 1 or 2 comparisons, okay, or 3, 4 comparisons, then we can say that it was an average case. Okay. What can we say about worst case in the t-shirt example first?
But it will be the last T-shirt that could be in the cabin.
Correct. Any another case? Yes, absolutely right, Sagni. But any other case?
It is not there in the cupboard, maybe.
Exactly. It is at the very end of your search, or maybe it is not there. Okay, so that can be one of the worst case, because see, in this worst case, what happens, my machine is running, it did the computation, so obviously it is going to take the time and the space, and at the end what it is giving, that the search is not found. So a little bit of your worst case scenario. Again, I'm mentioning this is not how the things work. This is just I'm telling you with this t-shirt example because we have not covered it in the theory session. Okay, fine. So the worst case scenario here can be 2 can be here at the very end, or it might happen that 2 is not there only in my entire array. Got it? The idea of best case,
Yes,
average
ma'am.
case, and worst case, everyone?
Yes, ma'am. Clear.
Okay. Now you implement this linear search in your comfortable language, C or C++, whichever you feel. Okay. First of all, go and implement this linear search, everyone. When done, just unmute yourself and tell me that it's done.
Ma'am, we should write the program now.
Yes, I told you that. This is the lab session. You are supposed to write the program. And see, one more thing, student, you are no more now, young students. You are now in higher semester, big students. You are like what, third year students, so you're juniors. You are no more juniors now. You are third year students. So please don't expect spoon feeding now. That you will be given a program to get copy pasted by a faculty, or the logic will be explained in detail with each one of you. So take a be responsible a little bit, and when you are coming up with the lab, please make sure that you are having the access to some compilers. I don't mind online compilers if you don't want to go with an IDE. Okay, I don't mind online compilers also, but you have to write the code. Okay, don't keep it like that we are doing it from mobile phone, so I'm not able to write the code. If you're doing it with mobile phone, use online compiler, but don't give me such excuses where I am getting a vibe that the student is not doing anything and they are just here for the attendance. Yogaraj, good.
I'm I'm done,
Yes.
ma'am.
Okay, everybody is done. Yogaraj, if you remember, if you can recall and you don't need any help with the binary search, you can implement binary search also. Otherwise, you have to wait for the explanation of mine. Okay. Finished, students?
Yes, ma'am. Finished.
Others? Those who have finished, and if you remember binary search, you can start implementing binary search so that in the next lab, when we are discussing time complexity, it is easier for you to see and compare the time complexity.
Okay, ma'am.
I hope everyone has finished now. Segni, there? Yes or no? Segni? I guess Segni is not there. Didn't answer. Should I remove? Thilaun,
Yes, ma'am.
present your screen.
Yeah, I almost done the first one.
It's okay. I just want to see. Present your screen.
You want to see my code?
Yeah, I want to see the code. Just present the screen.
Okay, okay, ma'am.
Thilawan, it's okay if your program is not completed. Just present me your screen. Okay, I can see it. Go down. Okay, stop presenting. Thank you. Thilawan, was it working?
Yes, ma'am. It's working.
Segni, there? You cannot speak. Okay. But I want you to represent your screen. If you don't speak, it's fine, but present your screen. Abdul Karim, I'll tell you after Segni. Okay, you also see language. Okay. Okay. But for loop, okay, okay, done. Fine. Stop presenting. Abdul Karim, you wanted to present?
Yes, ma'am.
Present.
It's visible, ma'am.
Yes. Zoom in a bit. Okay. Your array is static. Make it dynamic, okay? It is statically
Okay, ma'am.
given. Make it dynamic one. Okay, go back to the
Okay.
code. C++. All right.
Done, ma'am.
Yeah. Okay. Now once you guys
Thank
you
you.
can stop. Okay. Now once we complete this time analysis portion, okay, we'll come back to this particular experiment again. Maybe by that time we will be in this experiment only. But if we have finished it, okay, we will come back to this experiment only, and we will then do the time analysis portion. Like if you search for a given input, okay, how much time it is taking, how to calculate the loop, how to calculate in between the condition statements, okay, all those time and space complexities we'll discuss. Right now, you keep the code as this with you, okay, under the subject of Daa. Okay, now coming to the binary search. Anyone remembers binary search before I show you the DS part?
Yes, ma'am.
What is it?
In binary search, binary search right here. We had a tree, and then in which we had a root node.
You have to
Binary search.
repeat once again. No. Not in terms of tree here.
Okay, ma'am. I was doing in terms of tree. So, let me recall for binary search.
Normally in array,
Oh, ma'am, I forgot in terms of array.
okay, no problem. Anyone else? Yuvraj, do you remember?
Yes, ma'am.
Okay, Abdul Karim, you can tell.
Ma'am, we make an array and we have three values, and there is one value in the middle. So after we take a variable, we search for it if it is bigger than the middle value or less than the middle value.
Correct.
After
Absolutely
sorting
right.
the array.
See, this is what we did. Array, first of all, the requirement was array should be present in sorted manner. Your array should be in the sorted manner. So you see 5, 9, 17, 23, 25, 45, 59, 63, 71, and 89. You guys are recalling something, this visuals from your data structure? 7 months
What, ma'am?
back, 7 to 8 months back visuals. Are you guys able to recall? This is the same. That's why I kept the same example also, so that you're able to relate.
Not that much, ma'am. We take it in semester 3.
Yeah, but that's why I'm keeping it as the same, because if the view would have changed, it would be a little confusing to recall even. Okay. See, in binary search, the requirement is what the array should be present in the sorted manner. Okay. Now, what is the n value? That means the size of array 10. So 0 to 9. Okay. My array is sorted and the size is 10. So 0 to 9. And the data which I want to find is what? 59. Data which I want to find is 59. Now see, this particular thing, this thing is your algorithm. Okay. Or you can say the pseudocode. While my left, we are going to take two variables, L and R. While my L is less than or equal to R. Okay. While my L is less than or equal to R. That means the index values. L we are going to start from here. Okay. And R we are going to start from the last one. That is what we have seen. Okay. I have to do what? Try all the cases one by one. That data is equal to one mid. You are going to find one mid element. Okay. How you are going to find mid element? L plus R divided by 2. Right. So you will go to some mid element. Now case 1 is what? Data is at the middle of the element. That is the best case. Because in the first search itself, you get your search element. Best case. Right. So element found. Nothing more, no more computation to be done. Okay, suppose I'm not getting it. Then what you are going to do, data is, we are going to compare the data which is to be searched, that is 59, and the value at mid element. Suppose 45 is the middle element. So you are going to compare this data and 45. If the data is less than, if the data is less than the mid value, then you are going to search in the left portion. Okay. If the data that is to be searched is more than the mid value, then you are going to search in the right portion. And why we are able to do this? Because we know the array is in the sorted manner. Okay. And accordingly, we are going to get the worst case, best case, and the average case scenarios. Now, if you remember, we discussed this particular algo. This is the algo. That binary search, the parameters that you are giving is array, size of array n, and the data to be searched. Okay. Inside that, we are initializing the L value to the index value 0 and R value to the index value n minus 1. And we are finding out first of all the mid. Okay. And then we are doing this loop of while to test each case. And this is, see, this condition statement is representing your case 1. If middle, array middle is equal data, see, it is representing your case 1. Then this else if represents your case 2. Data is less than mid. So what I have to do, I have to go and modify my right side. Okay. And this else represents your case 3. Okay. So this is the logic, or what you can say, the algorithm, basic pseudocode. Fine. Now using this logic, you are supposed to build a binary search program. Okay. Using the same logic, you are supposed to build a binary search program. But this, you do it at home because it is 12:05. Okay. I am going to conclude the lab session for you. All right. So what so far we have done? So far we have done your linear search. You have implemented, I have explained to you the program and the working. For binary search, I explained you the working of this while loop. Okay, what is to be done and what not is to be done. This particular algo we have again seen once again. So now when you come into the next lab, next Wednesday, okay, I want you guys to be prepared with the two programs, linear search and binary search. Okay, then at that time don't tell me that madam binary search is left for me, I forgot to do. Then it is your work incomplete. I cannot wait further because see, we have to do the analysis part. Okay, and as these time complexities is little bit new for you, it might take time. So in order to give that time, I cannot, you also have to cooperate with me, and you just, come up, finish these two particular programs. Binary search, you finish it by the time you come to the next lab. Okay, and then we will discuss it in terms of C. Got it, everyone?
Yeah.
Yes, ma'am, clear.
Ma'am,
Yes, Suman.
can you see my code for linear search once? It is not running on Dev C++.
What is the error it is giving? Present your screen.
Okay, ma'am. Is it visible?
Yes.
Ma'am, it is giving error for for loop. It is saying,
Zoom in for me. I
uh,
can't read.
okay, ma'am. Okay, ma'am.
Control Shift
Yeah, ma'am.
Control plus something like that is the shortcut.
Yeah, ma'am. It's not working. I did it, but it's not working.
Go to view. You have magnifier.
No, ma'am. It's not working.
Wait, let me help you out. Wait. Okay. In that, just pinch out and pinch in. In your workspace only, pinch out and pinch in.
Yeah.
Okay. Uh, where was the error exactly? What was it telling? Compile
Ma'am,
this.
it's saying for loop initial declaration are only allowed in C99 or C11 mode. I googled for it and it said that the previous version of this compiler had to do something with this or something like that.
Okay. Your is GCC 4.5.2, something like that.
4.9.2.
Mine is also the same. Works for me.
Yeah, it is working in all-in compiler though. It's perfectly running the same code.
Then maybe there is an issue with the updation of the package. Try to update the package of that Dev C++.
Okay, ma'am.
Okay, Yograj. Done. Then you don't have to work for the week. Alright, Suman, you can stop presenting. Fine, students, I am concluding your lab here. In the next lab onwards, we will continue with this for the time analysis of both the experiments. Okay, thank you all for attending the session. Kindly write your enrollment numbers in the chat and you are free to leave the session.
Thank you, ma'am. Have a nice day.
You too. Students, quickly write your numbers in the chat and leave the session.